Want to learn Selenium without getting confused by too much theory? In this video, we'll cover the most important Selenium concepts with simple definitions, syntax, and real examples. Let's get started. Let's start with the basics. Selenium is an open source framework mainly used to automate web applications. It allows us to control a browser programmatically, just like a real user would. We can open a website, click buttons, enter text, read information, and perform many other actions. The main component we use for browser automation is Selenium WebDriver. In Java, for example, we create a WebDriver object and initialize it with the browser we want to use, such as Chrome. Once the driver is created, we can open our application using the get method. So, this is basically the starting point of a Selenium automation script. Now, let's see how Selenium actually identifies the elements on a web page. To interact with any element, Selenium first needs to find that element, and that's where locators come into the picture. A locator tells Selenium exactly which element we want to work with. Some commonly used locators are ID, name, class name, CSS selector, and XPath. For example, if a username field has an ID called username, we can use by.id to locate it. Similarly, we can use XPath when we need more flexible identification, especially for dynamic elements. Whenever possible, I prefer using a stable and unique locator because it makes the automation more reliable. So now that we know how Selenium finds an element, let's see what we can actually do with that element. Once Selenium finds an element, it represents that element using the WebElement interface. For example, a username text box, login button, checkbox, or link can all be represented as web elements, and once we have the web element, we can perform different actions on it. We can use click to click a button, send keys to enter text, and clear to remove existing text. We can also use methods like getText is displayed and is enabled to read information or check the state of an element. So basically, locating the element is the first step, and WebElement gives us the ability to interact with it. But sometimes the element isn't immediately ready to interact with. That's where waits become important. Imagine your application takes a few seconds to load a button. If Selenium tries to click that button immediately, the test may fail even though the application is working correctly. To handle situations like this, we use waits. An explicit wait tells Selenium to wait until a specific condition becomes true. For example, we can wait until a login button becomes clickable and then perform the click. This is much better than simply adding a fixed delay because Selenium waits only as long as necessary. We commonly use WebDriver wait along with expected conditions. So, waits help make our automation more stable and reliable. Now let's move on to some common browser controls that we frequently handle in Selenium: dropdowns and alerts. Dropdowns and alerts. Let's start with dropdowns. If we have a standard HTML select dropdown, Selenium provides the select class to interact with it. We can select an option by its visible text, value, or index. For example, if we have a country dropdown, we can select India using select by visible text. Now let's talk about alerts. Alerts are browser pop-ups that can display a message or ask the user for confirmation. Selenium handles them using switch to open parenthesis, close parenthesis, dot alert open parenthesis, close parenthesis. Once we switch to the alert, we can read its text, accept it, dismiss it, or enter text if it's a prompt. So, dropdowns and alerts are both common Selenium interview topics. Next, let's see how we handle frames and multiple browser windows. Frames and windows. Sometimes a web page contains an iframe, which is basically a separate document embedded inside the main page. If the element we want to interact with is inside that iframe, Selenium can't access it directly. First, we need to switch into the frame using switch to open parenthesis, close parenthesis, dot frame, open parenthesis, close parenthesis. Once our work is completed, we can return to the main page using default content. Now, what if clicking a link opens another browser tab or window? In that case, Selenium uses window handles to identify different browser windows. We can get all the available handles and switch to the required one. So remember, for an iframe, switch to the frame. For multiple tabs or windows, switch using window handles. Now let's look at advanced mouse and keyboard interactions. Sometimes a normal click or send keys isn't enough. For example, imagine you need to hover over a menu and then select an option, or you need to perform a right click or double click. For these advanced interactions, Selenium provides the Actions class. We create an Actions object and then use methods such as move to element, double click, and context click. For example, if a submenu appears only when we hover over a menu, we can use move to element to perform that action. The Actions class is especially useful when automating applications with complex user interactions. So we've covered mouse and keyboard actions. Now let's see how Selenium handles browser navigation and JavaScript. Selenium also gives us methods to control browser navigation. We can open a URL using get, and we can use navigation methods like back, forward, and refresh. These are simple but very commonly used operations in automation scripts. Now sometimes normal Selenium commands don't work easily for a particular browser-side action. That's when JavaScriptExecutor can be useful. For example, we can execute JavaScript to scroll down a page or perform certain actions when normal interaction becomes difficult. We create a JavaScriptExecutor object and use executescript to run the JavaScript code. So, navigation handles browser movement, while JavaScriptExecutor gives us additional control over the page. Next, let's talk about screenshots and some common Selenium exceptions. Screenshots are extremely useful when a test fails because they give us visual evidence of what happened on the page. Selenium provides the Take Screenshot interface, which we can use to capture the current browser screen. Now let's quickly look at some common Selenium exceptions. No such element exception usually means Selenium couldn't find the element. Timeout exception can occur when a required condition isn't met within the specified wait time, and stale element reference exception can happen when the page or DOM changes and the previously located element is no longer valid. Whenever we get an exception, we shouldn't immediately assume the application is broken. We should first check the locator, wait, frame, or window context, and the current page state. Finally, let's put all these concepts together in a typical Selenium flow. Let's quickly connect everything we've learned. A typical Selenium test starts by launching the browser and opening the application. Then we locate the required elements using suitable locators and wait for them to be ready. After that, we perform actions such as clicking, typing, selecting drop-down values, handling alerts, or switching frames and windows. Once the action is completed, we verify whether the actual result matches the expected result. If something fails, we can capture a screenshot and investigate the issue. Finally, we close the browser using quit. So, these are some of the most important Selenium concepts you should know for interviews and real automation projects, from WebDriver and locators to waits, actions, frames, windows, JavaScript, and screenshots. Keep practicing these concepts with real scenarios, and Selenium will become much easier to understand.